In this lesson, we will look at some examples to identify the oxidation process, the reduction process, the oxidizing agent, and the reducing agent. The first thing we need to do is assign oxidation numbers to each atom in the reaction. Magnesium is a free element and has an oxidation number of 0. Hydrogen has an oxidation number of +1. Chlorine has an oxidation number of -1. Magnesium has an oxidation number of +2. Chlorine has an oxidation number of -1, and hydrogen as a free element has an oxidation number of 0. Magnesium goes from 0 to a +2 oxidation number, therefore it is the oxidation process. We are losing electrons and the oxidation number is increasing or becoming more positive. Hydrogen goes from +1 to 0, so it is the reduction process because we see a decrease in the oxidation which results from a gain of electrons. Because magnesium is being oxidized, it is the reducing agent because it's causing another species to be reduced by itself being oxidized. HCl, which contains the hydrogen, is the oxidizing agent because itself is being reduced, which is causing another species to be oxidized. Remember, the agent causes that process to happen. The reducing agent causes another species to be reduced. The oxidizing agent causes another species to be oxidized. Let's look at another example. First, we need to assign oxidation numbers to every atom in the reaction. We start with the C2H6O2. Carbon is our unknown, but we know that hydrogen must be +1 and oxygen is -2. We know that the sum of the oxidation numbers must be equal to 0, so 2 times x plus 6 minus 4 will equal 0. 2x plus 2 will equal 0, 2x equals -2, and x equals -1. So we know the oxidation number of carbon is -1. For HiO4, we know that hydrogen is +1, oxygen is -2, and the iodine oxidation number is our unknown. We can again set up an equation to solve for that unknown value. 1 plus x minus 2 times 4, which is -8, equals 0. X minus 7 equals 0, so x is equal to 7. So the oxidation number of iodine in this compound is +7. Moving to the product side, for H2CO3, we know that hydrogen has an oxidation number of +1. Carbon is our unknown oxidation number, and oxygen has a -2. So we can set up our equation with 2 plus x minus 6 is equal to 0. X minus 4 equals 0, so x equals 4. So the oxidation number of carbon is +4. For HiO3, hydrogen has an oxidation number of +1, and oxygen has an oxidation number of -2. We set up our equation to solve for the unknown oxidation number of iodine. So 1 plus x minus 6 is equal to 0. X minus 5 equals 0, and x equals 5. So the oxidation number of iodine is +5. In water, hydrogen has an oxidation number of +1, and oxygen has an oxidation number of -2. Now we can look at which elements change oxidation number in going from the reactant to the product side of the reaction. We see that carbon changes from -1 to +4. We see an increase in the oxidation number, so this is the oxidation process. Iodine goes from +7 to +5, which is a decrease in the oxidation number, so that is the reduction process. The C2H6O2 contains the carbon which is oxidized, means that it will be the reducing agent. It is causing something else to be reduced. HiO4, which contains the iodine which is being reduced, is the oxidizing agent. By being reduced, it is causing another species to be oxidized.